As a bacteria to the result as a virus with the here you can see. Hello everyone. Today we are going to see the project name called AI-based pneumonia detection using D4 Equivariant Vision Transformer with the explainable AI. So in this project we developed an AI-based pneumonia detection system that analyzes the chest X-ray images using a D4 equivariant vision transform model. The system pre-processes the images, classifies them into bacterial, viral, or normal categories, and provides explainable results using a CRAD cam along with this SAP through a Flash web application. So this is our block diagram. First, we are taking the X-ray images. In that image, we are pre-processing with the class enhancement and normalization, and we are resizing, and we are using a data augmentation also in the image pre-processing. After the pre-processing, we are giving those images to our model. So we are using a D4 equivariant vision transformer model. After our model learn these things, in the result, it will be displayed along with the CRAD-CAM and SAP analysis. So in the prediction output, it should be a bacteria or virus or normal along with the confidence score and the CRAD-CAM and SAP. All those things we are integrated in the Flash web application. This is our training code. First, we are importing all the necessary libraries. So this is our data set directory. So this is our data set. Here we have a test and train data set. So here you can see for each class we have around 900 images for train. So here we are pre-processing. So here we are using a D4 transformation. So like for each image it will be rotated into 8 shapes. Like it will be rotated and resized and normalized all the images before training. So here we are splitting our data set. So here we are loading our class weights. We are using a 80 base patch 16 underscore 224. This is our model. So with this model only we are training our data sets. So with the epoch of 10 we are training our model. So from here our training is started. So once after pre-processing it will be give to our model. So our model will learn and it will classify whether it is a normal or bacteria or virus. Along with the confidence score, it will be learned. So after the learning, we will validate with our testing folder files. So at last, our model will be stored in the name of best pneumonia model. So after the model saving, we have a confusion matrix and the classification report along with the accuracy graph. Here you can see these are our training results. So here you can see we got a training accuracy highest as 89 and validation accuracy 86. So this is our confusion matrix. So we'll validate with our test files. This is our classification report. Here you can see the accuracy 86%. So this is our graph. So here you can see the training is in the blue color and validation is in the orange color. The training it reaches over the above 95. As a validation, it is reach 86%. So this is our app code. We are using a Flask. Flask is a tool to integrate the backend to the front end, and then we are using SQLite here. So here also first we are importing all the necessary libraries, and then here we are defining our class name. So this is our database. Our database name is users.db. Here you can see users.db. In the database, we are creating one table with the column names of name, email, password, and ID. So what are the things we did in the training code? The same things we are doing in the app.py also, like we are pre-processing and then we are transforming and then we are using normalization and resize for all the images before we are giving to our model. And after giving to our model will predict that and it will classify the class. So this is for a CRAD cam. In the CRAD cam, it will be displayed based on the which place it is took for a prediction. So those things will be displayed in the CRAD cam. Tab will explain the same thing only based on the image, which range it took for a prediction purpose. So these are our routers. So we have 5 routers, a home router, register, login, about and logout routers and along with the prediction route. So in the registration router, we need to register our name, email and password. Once if we register means those things will be inserted into our table which we have created in the users.db. After it will be redirected to our login page. So in the login page, we'll ask the email and password. So once if we give the email and password means then it will be go through our database and it is select the row if it is already registered, for a prediction, or else it will throw error like a invalid credentials. We have a logout button also. Once if we click the logout means, then it will be direct to our home page. We have a about page also. This is our prediction. In the prediction, for a prediction, we need to first log in. After login, once if you select the image means, then that image will be pre-processed. After pre-processing, it will be give to our model. So our model will predict and it will display the class name along with the conference code, the cradcam and the sharp image also. So to run the code, we need to type Python space app.py. It will produce one link. We need to follow that. So this is a link we need to follow. It will open in the web page. So this is our web page. So pneumonia detection using deep learning. We have a login, register, about, prediction and logout page. For a prediction, it will ask the login. So first we need to register. This is our register page. For a register, we need to provide our name, email and password. We need to click register. Once after register, it will redirect to our login page. The login page, we need to provide the same email and password which we had used for a registration purpose. So once after login, it will redirect to our prediction page. So this is our prediction page. First, we need to select the image. So I'm selecting a bacteria image. So here you can see the image selected. So we need to click analyze image. So once after analyze, will show the result. So here you can see the result is a bacteria to the confidence of 99%. Here you can see the SAP analysis and cam also. We'll check with the another image. Here you can see selected image is a bacteria only with the confidence score of 97% along with the cam and SAP explanations. We'll check with the virus analyze image. So it's processing the image. It's after processing. Here you can see the result is a virus with the confidence of 99%. Here you can see the cracker, the SAP explanations. We'll check with the normal. So here you can see normal only with the confidence of 97% and the crackdown and SAP explanations also. You check with the another image. Now I'm taking the virus analyze image. We need to click. So here you can see the result. Virus only with the confidence of 93% along with the crackdown and SAP explanations. So we'll back to home. This is our about page. So in the about you can see about of our project. So if you click the prediction means now we are already logged in. So it will directly allow. Once if you log out means, then if you click the prediction means, then it will ask us to log in. Once after login only, we will predict.